this is the talk about GraphRAG with the knowledge graph. So let's kind of just do a very quick show of hands who heard about knowledge graph before. All right, and who heard about GraphRAG before? All right, that's a pretty good audience, right? This is more than you usually have, so this is good. So about me, on top you have all my handles. So I'm chief scientist everywhere. It's not made up. I've been the chief scientist of a public company called Nitro, which was an early leader in smart documents. So we applied machine learning to PDFs when it was not sexy. And they're very boring. And it's still not sexy, but it pays the bills, right? So contracts, all kind of business documents, leases, very interesting area. So we use Spark and kind of early approaches in NLP to do that. I'm at chief scientist everywhere where it basically exists, on Twitter and Telegram. I'm chief scientist.org on the web where I blog on my Medium, and I'm chief scientist on LinkedIn. So I'm now AI community architect at Neo4j, which is a devreal function. Yolande, my colleague, is here. I'm extremely excited to be in devreal because we get to play with code, and we connect graphs, open source AI people, and also alliances like AI Alliance. I'm actually a co-founder of the AI Alliance, which I set up at IBM, helped set up with Meta and 100 other companies. And I personally brought in Databricks, Anyscale, LangChain, LlamaIndex, Snowflake, and a bunch of others, and universities like UPenn, Berkeley, Dartmouth, Northeastern, and essentially all of the folks I knew in the community. So it kind of comes very handy when you know a bunch of people. If you need to do something like this, you can actually invite a bunch of people who understand why they should do this, and they come. And my really favorite, one of them, organizations I helped build is opensource.science. You can see that on my t-shirt. This is a URL, opensource.science. And that's at NumFOCUS. NumFOCUS is a Python data stack home. It's a nonprofit foundation. Who heard about NumFOCUS before? Very few people. Who heard about Pandas or Jupyter or NumPy or SciPy? Right? This is all in NumFOCUS, right? So check it out. Donate to it if you can. And so we connect open source researchers with open source developers with scientists, right? So accelerate science with open source. And I have a pet project there, which is a map of science built with Neo4j. So if you want to help us, we're building a map of all open source ever used for science with papers, projects, and so forth. So talk to me if you're curious about that. So I'm also a founder and organizer of communities like this one. And I run the conference called Scale by the Bay, which I founded 10 years ago. Hopefully we'll bring it back next spring. And that's basically like this, but times 60. Right? So we have 3 days full of talks on 3 tracks. Data engineering, software engineering, and AI at scale. So, and finally, I'm a photographer. You can not just carry my camera, don't mind me. I make a lot of pictures, I publish them, and you can probably find yourself in one of them. And I also like kids, cats, and dogs, and I have them in the ratio of 4:1. Okay, so a brief intro to Neo4j. Who heard about Neo4j before? Well, this is really an advanced crowd. I'm really appreciating you guys. So just kind of to catch other folks up, Neo4j is a graph database. It's actually a category-defining database. There are no commercial graph databases. It still feels like a startup. It exists, for more than a decade. And basically, it's a database, right? Primarily, it's a database. And if you notice, any serious IT business has to have a database. All the data should be somewhere. So the biggest companies like Oracle now, Databricks, Snowflake, they're all databases. It's not, there is a reason for this. And the cloud companies build their own, right? So Google uses BigQuery, this public version of the internal Bigtable. Facebook has very similar stuff. Who is like the old adage goes, who's the closest to the data has more power, right? And actually it's interesting, like inside of the big companies, whoever is closest to the data stream wields more power in these companies because they can process this data, understand it, and do something with it. So we stored it in a graph, and we do analytics on a graph. And who here knows what graphs are, right? Who has computer science education? Who is a computer scientist? Okay, who is not a computer scientist? Let's see if it adds up. Not really. We have tertiary logic here. But what happened is it's really phenomenal. I found that it's not a given anymore, right? We have such an influx of people in AI programming, AI engineers. A lot of them did not know what graphs are. So graphs, it's phenomenal, but that's true. We need parameters in graphs. I'm not going to do one here, but I'll do one kind of I make a point. So everything now, majority of data, is stored in relational databases. Who works with relational databases? Yes, MySQL, right? Anything. SQL is everywhere. So what happens is you want to connect persons and assets, right? And in order to do that, you basically have a table. Every table has a unique ID. Every row has a unique ID. Usually person or asset will have a unique ID. And then you basically need a table, right? Person, asset, which will just list IDs. And so if you do a join, right, like this is how you connect persons to assets through that table. And so now you have this structure, which is effectively a graph, right? So you can say a person owns an asset. And instead of having this intermediate table, you have a relationship. This is how you naturally think of data, right? Person owns assets. So if you think of this, it's very strange that we got to store our data in relational tables, because this is not how we think, right? This is not how data is actually organized. It's not naturally stored in these tables. So we have this graph, and now we have at Neo4j database which can efficiently store these graphs at scale, and really it's very hard to do it at enterprise scale, and we, I think, are the best company to store it at high volume. But we also can query it, so there is a language called Cipher that it looks very nice, it looks graphical, right? So nodes are represented as these parenthesized labels, and then you have relationships, right? And there's like a little arrow. So it's almost graphical. And so instead of SQL queries, you can actually issue Cipher queries, and now it's been standardized as GQL, Graph Query Language, which is the first query language standard in 40 years after SQL. So there is basically now, I think, understanding that this is as important as SQL. So, and basically to sum it up, right, we use property graph model. So you think of your data as objects with properties, right, and they have relationships. We have graph data science library available, which runs all kinds of algorithms on these graphs, so you can find shortest paths, right? You can find clusters, cliques, and so forth. And it's used in many critical use cases, right? So it's very naturally used by financial companies to find fraud, because all kind of actions, all kind of human interactions are naturally used, modeled with graphs, and a lot of three-letter agencies are using this for the same reason. So there is basically any social network, you have a natural application for this. So now, what has to do with GraphRAG? So 3 sources of data in GraphRAG. So we have unstructured data, right? We have a bunch of text, your dark data, your company, internal data, PDFs and Excel tables, and a lot of stuff which is not on the internet and nobody knows how to find stuff in it, including Slack, right? And when you ask, what's Apple's primary business, then you basically have like internal Google. You can drop everything in Lucene or Elastic, right? And somehow it will actually give you not necessarily the answer, it will give you a bunch of documents which maybe have the answer. But I must give credit to my colleague Andreas Kolleger, who basically built all these slides and stuff, right? It's my 3rd week on the job, so I'm shamelessly using everything I can find. Mediocre artist copy, great artist steal. So this is direct stealing from Andreas, and I think he did a great job here. So now pure data, right? So we have actual data, like I said, stored in databases. So we have structure, right? People spend a lot of time carefully curating, validating data. Usually these databases have schemas, constraints, unique IDs, they have to be well-formed, emails has to be an email and so forth, right? So structured data. And now basically answers from this data look like numbers. So if you're a SQL analyst, you ask a SQL query, it comes back with either a number or a string or a tuple or a vector, something very rigidly expected. Right, now the fun stuff happens in the middle, right? We want both, right? Not have both, right? So we need somehow to connect these things, right? And this is not easy. This is where LLMs fall on their faces and a lot of stuff goes wrong, because one thing is fuzzy, one thing is rigid. How do you connect them? Right, and so the interesting question, which investors will be impacted by a chip shortage? Like this sounds like an interesting question, which is hard to answer. It's really hard to answer by any of these traditional techniques. So we want to do this, right? We want to attack this, so we have basically a way to use GraphRAG. So we're going to use a knowledge graph. So knowledge graph is an architecture. So generally speaking, my view of this is that knowledge is something that only humans can decide, right? If you think of knowledge, it's not what computers do. Computers spit out outputs. They output strings, they blink with pixels, they just do mechanical things. And you can interpret them as content, right? So essentially, Andrej Karpathy said, like, there will be no programming languages anymore. You will be inputs, giant LLM, and it will directly visualize things on the screen with pixels. Like, it may be text, it may be image. They can like rip out complete infrastructure of the internet and just go directly from your sensor input, your keyboard, your audio input to pixels. So a machine probably will learn how to do this. So like, it will just show you what you want. It may not know at all what it's doing. It's optimizing the pixels that you're going to see and make noises and whatever, like smells in the future, right? It maybe will plug into your neural link and create images in your brain of the kind you want. But it's just doing whatever it learned in the process. Kind of knowledge is only something that humans can say. It is knowledge. So we always need humans. And humans are not going to replace, AI is not going to replace humans. At another talk, which I heard at Stanford Industrial AI Conference, my colleague, former colleague from IBM, Dmitry Zubarev, who is a chemist, computational chemist, said AI cannot be a stakeholder. AI cannot have ownership, right? So similar thing, like humans are stakeholders, and humans own knowledge. So I think it's very important that knowledge graphs are created for humans. They can be automatically created, but humans are going to use them. Humans are going to look at them. Knowledge graph is for us to organize our knowledge. So ultimately, it's something which is a technosocial, which exists for humans. It can be used, by machines. It can be built with machines, but we need to understand what's going on. So what is GraphRAG? GraphRAG actually uses a knowledge graph to do information retrieval, meaning search, query, and discovery. Because it works with a knowledge graph, it, in this way, dehallucinates LLMs, it ground truths them in human knowledge. Right? So there's implicit understanding that our human knowledge is there, and humans are going to find this useful. So how do we do this? So we have vector search, we have graph queries, and in the middle, we connect them. Right? So we do search and pattern matching. So, and also remember, now we are moving to these compound systems with agentic architecture. We don't have to do just one thing. We can do a vector search, we can get a bunch of vectors, and then we can go find things in these vectors, and we can go, like maybe they're nodes, right? Maybe they're IDs of nodes, we can go in the graph, we can traverse the graph and find interesting things. We can go to the upper, like subclass or superclass. We can find a person, we can find a manager, we can find kinds of people they are, and we can repeat this, right? So this is a compound system. So here's an example. We have, SEC Edgar financial data. It's a very well-known database, strangely by programmers who are not usually financial people. Who heard about Edgar? A few people, right? So this is something which publicly traded companies have to file, right? To basically update the public that they're not going to fail. And so all the critical risks and the kind of state is there. And for 30, this is what investors have to file. And so it's a lot of fun, basically, to merge these two things. And they're extremely dirty, they're kind of messed up, so they're unstructured data. But they have some structure which we have to obey, right? So there are metadata, there are names of people who invest and so forth. So how do we model this? So the key strategy is a minimum viable graph, like you have in the startup minimal viable product. You build a minimal viable graph, and you do it in these three stages. You create the nodes and the relationships, and you enhance them, right? So you can put anything in a node. It can be a bunch of embeddings. It can be, a lot of different things. And also the relationship, this edge, can also have any random data in it, right? So you basically, anything you know about every node and their relationship you could put in the graph. And then you connect, right? And then you look like, how can you connect these nodes? Are there relationships between them? Just like we do, as humans. So here's an example. So what do we do with this Edgar database? So we take all these forms and we chunk them. And you will hear about chunking, I hope, from other folks talking about RAG. But that's a very typical thing. So for now, we just do what RAGs do, what vector RAGs do. We chunk them, and we embed them. So we replace chunks by embeddings. We get a bunch of embeddings. Now we're still a vector RAG, right? And we now link them. It's already interesting, right? Like, it's not just random chunks. It's not floating in soup. They now have a link. We know they're connected. Still not much, right? Like, it's still kind of very mechanical. So we create them, and we have a schema, right? It's already interesting. We have some kind of formal linkage. But now it becomes really interesting because we know they all belong to a document, right? And so what we do, we create the summary of the document, which becomes the head of the list. And then we create a link from every chunk to the summary, right? So now we can always go back from the chunk to the summary. And if whatever happened to be in the chunk is kind of seemingly unrelated, we still can find that that's related, right? So that's already interesting. Now we take 4 and 13 and really go to town, because that's a really fun thing for graphs, right? It has all the managers, and it lists what stocks they own, right? To see that there is no conflict of interest, and they own stocks in companies. So we just put everything in the graph. And also they have to list addresses. So we can really have fun here, because we can put addresses there, and we can have like poor man's geospatial search, because we can actually use Google Maps, right, to put them and find proximity. So this is really fun. And now we can put it all together. So this is kind of the combined graph, and now it really looks like a graph, right? It's like we have a lot of fun stuff in it. So, and then this is basically a summary of what happens here, right? We started with a bunch of forums, and now we have this really rich graph, which has chunks of things. It has summaries of forums. It has managers, companies, and addresses, and it's all linked together. And we built a bunch of indexes. Nothing prevents us from thinking this is all a bunch of documents. So we can just put it all in a full text index, right? We can have your TF-IDF whenever we want, but we can also have a geospatial index, and we have our links. So this is not an end yet. I'm going to show some code, but I'm going to stop here. This is enough of the slides. I'm going to maybe get a few questions. And so these are the links. So the top link is the GitHub repository with all the code, which I'm going to allude to. The second link is the short URL to the slides. It's Google Slides, so you can see them. All of the videos from 2013 from our meetup are going to functional TV, which has more than 1,000 talks from the meetups and conferences. So you can find these videos there in a few days, because Matt is extremely efficient. And he was doing this from 2013. So let's give a round of applause to Matt. He's recording this always. Then we have an amazing Graph Academy. So everything I said, if you need to dig, like they now delve into this, you can go to Graph Academy, which Neo4j MS. So when I joined Neo4j, this was the easiest and the best onboarding, because they have these amazing resources. They're really, really good. They also do course with deeplearning.ai with Andrew Ng on this, right? So I highly recommend you go and peruse this. You can spin up cloud instance of Neo4j for free. You can get your Neo desktop for free. So there is a super easy curve. This is my email. You can email me. And as I said, I'm chief scientist everywhere. And one more thing. So because we are DevRails now, I want to really convene a new community called devreal.ai. So this will be what DevRails should do to help developers learn this stuff. And I think we did some interviews with the speakers. We're going to publish them there. We're going to cross-post all kind of DevRel content. We're going to invite cool kids from everywhere who are DevRels to share their knowledge, right? So this is going to be useful resource. There's nothing there yet, but it will be very soon. So keep an eye on it. So now let me see. I can take questions now, or maybe, you know, in the interest of time, I'll show you some code, and I'll just take questions in the end. Okay, so that's the code. So this is very interesting, right? So this is the repository, right? So what it does, I'm just going to focus on one notebook. And the beautiful thing, by the way, this is, you know, VS Code. You can run your notebooks in. You know, I was out of Python for a bit. Like, I'm super amazed how far the ecosystem has gone. It's really a pleasure. Like, you know, if you like run, if you know Shell and Python, like in IDEs, it's super amazing. So yeah, so this is basically a notebook. You can run it in Jupyter, but I prefer to run in VS Code. So what happens? So the previous notebooks here, they do this minimal viable graph. So all the Edgar database is prepared, right? All the hairy stuff is taken out. And so it's right here in the repository. So it basically parses it. It creates everything I said in a Neo4j instance. So this is, by the way, what Neo4j instance looks like. It's a beautiful code and beautiful setup. So it's the Neo desktop, get it for free. It runs an instance of local Neo4j database. It has the Cypher browser where you issue your commands and all the history. It has all the instances and nodes conveniently extracted here. And it has this beautiful visualizer called Bloom, so you can see, and that obviously all of this is scalable, right? So you can actually drop your graphs in this and explore it. So I'm connecting from VS Code. I'm connecting to that instance. and I already have all this stuff in it. So I basically use LangChain. Another beautiful thing about open source, Neo4j plays with everybody. It turns out this is so useful. We integrate with LangChain, LlamaIndex, Pinecone, which Roy is going to talk about, Zealous with Jung is going to talk about, V8 and everybody else. So we can integrate basically with all the major rags and open source packages for LLMs because they find it useful. So we're going to productize our LangChain integration in a few weeks. It's out. It's going to be officially supported. LlamaIndex and so forth. So this is really great time for open source AI. So all of this stuff is supported, right? So basically what I do, right? I set up my things. I talk to OpenAI LLM. I have my credentials, the usual stuff, all right? And so vector search. So first of all, you can treat Neo4j as a vector RAG because all the text is just a bunch of documents. So you want to completely ignore all the links. You just treat it as a vector store, right? So I have now vector store search, right? And so there is a company that's called NetApp. So if I do, if I do this search on NetApp, it tells me where is NetApp headquarters in San Jose, California. If I and then I can ask more questions. I can ask, what's its primary business? And it gives you an answer. This is the vector RAG, right? And then I can ask about investors. And it says it's not mentioned in the provided content because the documents themselves do not say easily who is the investor. The RAG cannot find it. And this is a very primitive RAG. I'm sure Pinecone and Milvus can find it, but this thing cannot, right? And what are its products? And vector search will tell you what its products are. And this is all, remember, is coming from this form. So this is not bad. Some enterprise software. Now, really fun things happen. So what now you can do? Like, look at this. It's a thing of beauty. You have your text query, but now LangChain has the notion of retriever, which basically, now that I got a bunch of objects back, what I'm going to do with them? And because it's a GraphRAG, what comes back are nodes and relationships. And now we can match. So what you see here, this is a Cypher query. Right, and basically, this is a representation of a sequence of chunks. It's a kind of regex for chunks, right? So we have nodes, and then we basically rank them, right? And basically, we use the Cypher query in addition to do something with the results, right? So that's a query window. Now let's do a comparison. So we say, who is the most important? What is most important to NetApp's business, right? And you get two different answers. The top answer is vector only. The second answer is vector and the query, the window query with some rearrangement of the nodes, right? And the first thing is very bland. It's like what you see in market presentations, right? Data management, cloud storage, cloud operation markets, right? Well, the second thing is also kind of businessy, diversified customer base and partnerships with leading cloud providers. So it's already kind of a little bit more, but you can still, it's a wash, right? It's not like exciting. So now you mix text and data, right? And you basically add, you add more Cypher to this. Right now we're basically merging what we know in the graph with, so we're not just re-ranking the vector output using nodes, we're actually using Cypher query. And that should be more fun, right? So let's compare that. Who is NetApp's top investors? So the vector search comes with nothing. Vector search with ranking comes still with nothing because the first thing was nothing. But the knowledge graph obviously knows about it because we built this, right? So it says basically top investors are Vanguard Group, BlackRock, and Prime Cap Management. Amazing. And now the final kind of most amazing question. So what we can do, we can generate Cypher from text, right? So we have text to Cypher generation. So we basically say we want the query for the graph, which will do this. Right? And Cypher, as you have seen, pretty involved. So the thing just goes and creates a Cypher query, which optimally reflects what you want to find in the graph. And it goes and finds it. Right? So we do that. So it's kind of enormous. Right? And now we compare everything. Right? So we have vector plus ranking by nodes, and then we have Cypher and text to Cypher. So most important, so we have this kind of wishy-washy two things. And the vector and graph says cloud-led, data-centric software services. It's kind of more interesting. Hybrid multi-cloud. Okay, that's fine. But let's look at the investors, right? Which was failing. So the vector found nothing. The rank found nothing. The vector augmented with graph gave a few, right? It gave Vanguard, BlackRock, and Prime Cap Management. And the Cypher query found all of them. Vanguard, BlackRock, Prime Cap, Capital International Investors, and State Street Corp, right? Found all of them. So, and then there is some geospatial search, which I'm not gonna run. All right, so then you can do a lot of fun things. So basically, that's, the end of my little demo. So what's really exciting, right? Like you can really play with all this stuff. You can look at the graphs, and we don't really know what's the right way to do it. So Roy told me like, these things work, these things don't, and I don't have the answer. The super fun thing is there is a lot of things to play with, right? Like you have just strings, it's kind of voodoo magic, right? And you can kind of rearrange them. I'm really excited about this way because it can optimize these queries. So I talked to Michael. He says we can do that. So I'm really now hopeful we should connect. And like this, as you have seen, this query which has a prompt and a chunk of the query language, hopefully we can optimize it as a part of the system, right? But in general, if you are a computer science geek, if you love graphs, like now we can bring all your forgotten graph algorithms, you can dust off your skills and you can bring them to bear on this stuff. So this is super exciting, and basically it connects to everything computer science is good for, right? And now we have a super fun database to play with. So I invite you all to try it out and check it out and talk to us if you have any questions. Thank you. So I'm gonna bring back this question slide so you have more time to remember the URLs. Maybe somebody can help me with the mic to bring it to people. Well, you have a camera. Oh, maybe Yolanda can do that. All right. Yeah, so please wait until they bring you the mic so we can record it.
Do you have any strategies to prevent the data from becoming stale? Is there a way to, ingest a new investor report, and if some of the investors have changed, being able to find these nodes and just update those and not rebuild the graph from scratch? Is that something that is possible?
This is super interesting, right? Again, I have this pet project called Map of Science, which I want to update regularly with new papers, right? Like same question. So the graph itself is not natively time-stamped, right? So basically, but you add nodes to it. So all your new investors, when new investors come, you will just drop them in the graph. In the next query, we'll pick them up, right? So this is not a model we should train. The knowledge graph is consulted upon every query. So in that sense, there will be no staleness, right? Like the new documents, basically, it's your pipeline. It's not the setup of this GraphRAG, because as soon as new documents drop an Edgar, you scrape them. It's how you set up your, filling of the RAG. You pick up a new document, you parse it, you put in a vector RAG, you drop nodes in the knowledge graph, and the next query will run against them. Yeah. So I think it's the data engineering setup.
Hello. My question is probably not something you would encounter a lot not a scenario you would encounter a lot in a machine learning based application necessarily, but I'm curious about graph databases and what optimizations or what support exists for doing aggregate style queries on graph databases. So an equivalent of that question would be, how many investors does NetApp have, as opposed to who are the top K? So running aggregate queries,
Yep.
Are there any optimizations on graph databases which make them faster than the current?
Yeah, I mean, the key point of the graph database, it doesn't care, the notion of aggregate query in that sense does not exist, because an aggregate query is your convoluted SQL, which does 3 million joins and then it fails, right? After actually a dozen. So in this case, you do not need this. If your data, you can follow 12 links, right? And it will basically match them. Again, I need to catch up a little bit on the performance bottlenecks, but the main idea of the graph database that if you have deep relationships, it will basically follow them, right, to the end of the earth. This is not a limitation how long the chain of this will be, right? It's not constrained by like SQL, by number of joins, because it kind of blows up in memory, right? It's structured differently, it's structured specifically to have these queries run efficiently.
Thanks for the talk. The question is, what's the current status of the text to cipher with language model, and what could be any suggestion to make it very robust? For example, I saw like providing few shots or maybe providing the schema.
Yep. Excellent question. Again, catching up. Like, first of all, so like a lot of this text to cipher is developed as examples, right, by DevRels. Now we have an engineering team which takes what DevRels do and productizes it. And what's really fun about text to cipher, we have people like totally volunteer, right? We just did a podcast, so I recommend you like find Neo4j podcasts. And so Alexander Erdl does this Neo4j live. And so a few days ago, he hosted a developer who just came up with amazing text to cipher implementation, like really deep, using LoRa, like effective, right? So what we're gonna do, again, don't hold me to it, I think we're gonna productize one of these versions. So I know that our engineering team is working on doing this, and so the model how they do it, they basically pick best of breed, right? And we kind of put it out, and then we firm it up and we productize it. So I believe it will be officially supported text to cipher implementation you can just take. But there is a bunch of them in the community you could use, right? And so including like, if you take the one which was released like a few days ago with a podcast, it's fun because you can see how it's done. You have great educational resource, and then you can go and use it. Good question.
Hello, this is more like a opinion question for you. So this is something that I tried like a year ago with Neo4j and LLMs. So what is your opinion about using, like doing this text to cipher for factual correctness checking? Because knowledge graphs are factual databases, and you can always convert into cipher and verify that things are right, and then create a data set out of it and then do things with it. So
I think that's the best use case, right? Because first of all, GraphRAG is not a specific architecture. In my mind, it's a family of architecture. So if your customer, like Neo4j customers, have knowledge in their graphs, if you already have a graph, you do not construct it on the fly, right? You actually have one. And so what you could, like, we just built one meticulously, right? We kind of went through this. We don't create it on the fly. You can create a graph on the fly from your documents if you need to, right? Kind of extract entities from a prompt and make a little graph. But if you already have a graph, like we did with investors, right, then we ended up with creating a query, just running the old-fashioned query, right? We don't need any LLMs for this, just fetches all the investors, right? Like we use LLM as a kind of wrapper to just route it to cipher. So if you do have a knowledge graph, obviously that would be great. So I would like to see more of this kind of, to me it's super interesting, how can we create a lot of these graphs using LLMs, then validate them using experts, right? And maybe human in the loop, maybe do spot checks. Like it's a very interesting question. High confidence validation at scale. Can we like, maybe high confidence can automatically accept, and like some low confidence we can feed through humans, right? But that would be super interesting. Now you have some kind of graph, which you believe is knowledge, right? As I mentioned before. And then you run queries against it, and the LLMs will help you to ask the right questions. And if something is not in the graph, you keep adding it to the graph. And you increase your knowledge, and now you're sure your knowledge is correct. I mean, that would be one way to do it. So, yeah, absolutely.
Thank you for the presentation. I've used Neo4j, and I was really impressed with the Bloom tool. I'm surprised you didn't show it in its full animated form. So I put my data into the graph, and I was able to just play around with Bloom and see a lot of relationships, because I could see hundreds, maybe thousands of connections at a time, and look at different relationships. So I got a lot of familiarity with my data just having that visual graph, just having Bloom. Second thing, and this is a technical question, when we create our vector embeddings, can we create those within Neo4j, or do we have to create them externally and push them in?
So I think in this example, we do this in the Python script, right?
Okay.
We feed them, but we put them in the graph, right? So it's a good question. Like, do we have functions? We have a lot of external functions, but I think it's it's up to you what to use for embeddings. I mean, it's a good question. I will check, right? Because you can probably configure some functions in Neo4j. What happens when you add a piece of text, have some hooks, right? But I think, I don't know specifically. It's a good question, but you can do it easily one way or the other.
Okay, I was doing it right then. Thanks.
All right. Very
Thank you very much.
Thank you for your Bloom. Again, I'm sure you know more about Bloom than me because you played with it a lot, and I just started recently. I hope to catch up to your level soon, right? But please come and show us Bloom, right? Like this is, maybe next time, right? We should do some demos because it is amazing. We just did this presence at AI conference. We had booths with demos, and people did play with Bloom a lot. So I guess we'll probably have to stop here because we have 2 more speakers. So let's see, it's 7:20, so we can do one of 2 things. We can just chug along, right? They have 2 more talks. We can do a 5-minute break, get some refreshments, and come back, but only on the condition that you do come back, right? Like, how about that? Who is for staying? Who is for breaking? Who wants to do a break? Okay, let's do a 5-minute break and come back, all right? But when I call people back, please do come back. I know this may not be easy. So the next talks will be Pinecone and Zilis, and they're gonna especially kind of how VectorRAG and GraphRAG work together from the primarily VectorRAG providers. So this is gonna be super interesting. So I really recommend that you come back in 5 minutes. Cheers.